Good afternoon, engineers. This is Muralidharan. I'll be teaching in few classes about MATLAB, basic MATLAB only. I'll not be teaching anything about toolboxes because the toolboxes need domain knowledge. After teaching the subject, I will teach the toolboxes later actually. So MATLAB stands for Matrix Laboratory. So we will deal basic MATLAB commands. Before that, just I will start with basic number system actually. Everybody knows what is an integer actually. Integers are nothing but whole numbers. There is no fraction. For example, -1, -3, -5, +10, +20, etc. are called integers. Then comes rational numbers. Rational numbers. Rational number means it can be expressed by a ratio of two integers, a divided by b. A and b are integers. For example, -7 by 3 plus 2 by 7 minus 5 by 1, etc. All are rational numbers because the numerator is -7 here, denominator is 3, so both are integers. Like that, second one, numerator is +2, denominator is plus 7, so it is a ratio of two integers. So this is called rational number actually. Then comes irrational number. Irrational number means we cannot express as a ratio of two integers not equal to a by b. A and b are integers. We cannot express actually. For example, square root 2. Square of square root 2. We cannot say it is equal to a by b. A and b are integers. We cannot express as a ratio of two integers. We cannot express. Like that pi. It's an irrational number. We cannot express as a ratio of two integers. B and C put together, combined, are called real number. Integers are a subset of real number. Like that, rational numbers and irrational numbers are a subset of real numbers. Then comes complex number. Complex number. Take square root of -1. Let it be some a or some p. Let square root of -1 equal to p. That means p square equal to -1. There is no, in real set, there is no p, such that p square equal to -1. We cannot tell any real number the square of which is a negative number actually, because if it is p is positive, positive into positive, positive, p is negative, negative into negative, positive. So no value of p can have square root of minus 1 actually in real set. So we go to complex set, complex number. Square root of minus 1 is expressed by either I or j. For example, let a complex number a equal to 3 plus j4. This is called the real part. This is called imaginary part. If you want to express in a coordinate system complex number, a will be 3 times in x-axis or real axis, 4 in imaginary axis. So this is 3 plus j4. So real of a equal to 3. Imaginary of a equal to 4. This is called rectangular form. This is nothing but real and imaginary form actually. We can express complex number in polar form also. We can express as a magnitude and angle actually. E power j theta equal to cos theta plus j sin theta. Let x represented in polar form 2 into exponential j into zero point 0.5. This is called magnitude. This is phase or angle. Any complex number x given in a rectangular form a plus jb can be expressed as in polar form or angle theta, or is magnitude given by square root of a square plus b square. MATLAB command absolute x gives magnitude, absolute x, angled x is phase. Phase is always minus pi to plus pi radians. Within this, so you can use MATLAB command absolute to find the magnitude, angle to find the phase. Uh, Keep in mind phase is between minus pi to plus pi. MATLAB always give phase in between minus pi to plus pi. Suppose if the angle goes beyond pi, then it is a wraparound actually. For example, if the angle is pi plus some epsilon, so it is greater than pi. So to bring back within modulo pi, we subtract 2 pi actually. pi plus epsilon minus 2 pi. So this is minus pi plus epsilon. So this is again minus pi to plus pi range. Try some example. Minus 3 plus j4. Find absolute. Let y equal to minus 3 plus j4. Find absolute value of y and angle of y. Find using MATLAB commands. And again you convert into rectangular form. For example, 2 multiplication multiply by e power j pi by 4. You convert this into rectangular form using MATLAB command. We'll do that. So the answer is 1.4142 plus I into I multiplied by 1.4142. This is in rectangular form. We can use either I or J. MATLAB uses I, but engineers in general we use J. J is nothing but square root of minus 1. MATLAB in general we will be using four windows actually. One is where the folder current folder is stored actually. Current folder and files are given. Second is called command window. Third is the editor actually. The program or code is in editor. Fourth is the variables actually. Whatever variables you are using, we can show them in a window actually. I will show four windows actually. Open MATLAB, we can select layout actually. So there are four windows. Here in this current folder, all the files are given actually. In this, the code or program is given. This is the editor actually. This window is called command window. Whatever command we can enter actually. For example, you can say h equal to, we can give us a matrix 1, 2, 3. This is a vector. We can display a h. In command window, you can enter. Another is workspace or variables. We entered h, the variable h as a vector. That is seen in workspace actually. These are four windows actually. This current folder contains all the files within this window actually. This folder contains the code or program. You can have some more windows actually. I'll teach about the basic things. For example, here you go to the preference. You can choose the font size. Now 16 is chosen actually. You can have 22. If you want higher, bigger font, you can increase it. Now I'll explain how to enter either a vector or a matrix. MATLAB works better if you can represent all operations in terms of matrices. For example, let A equal to 1, 2, 3, 4. This is a vector actually. This is called row vector. This percent symbol represents comments. After that, whatever you enter, it won't take into account. This is called comments. This vector is called row vector. It has only one row and four columns, one cross four. We will display what is A. So 1, 2, 3, 4. It is a row vector because there is only one row and four columns. Then we will go to, then we will see how we can represent a matrix. Let B equal to 1, 2, 3. So this is forms one row. Next row we separate using semicolon. 4, 5, 6. This is second row. Separated by a semicolon. Third row 7, 8, 9. This is a 3 by 3 matrix. Let us display B. Type B, just press enter. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is matrix B. This is a 3 by 3 matrix. First we dealt with a vector. Vector could be either the row vector or a column vector. For example, let C be C equal to 9, 10, 11. So this is 3 cross 1. Each row is separated by a semicolon. Let us display C. 9, 10, 11. So it has 3 rows and only one column actually. Whereas a matrix has both rows and columns. Whereas this one is a vector. It is a 3 by 1 vector. Let us display B again. 1, 2, 3, 4, 5, 6, 7, 8, 9. There is something called inverse matrix. Inverse of matrix. We will talk about it later. We can add two matrices, subtract, we can multiply two matrices also, but that is not always possible. Suppose there is a matrix A and there is another matrix B. Matrix A has m rows and n columns. That matrix B has n rows and p columns. The product matrix A cross B, A multiplied by B, will have m rows and p columns. It will take rows from matrix A, columns from matrix B. For that, the matrix A and B, if you want to multiply two matrices A and B, the number of columns in matrix A must be equal to number of rows in matrix B. Otherwise, we cannot multiply actually. Here, the number of columns in matrix A is n. The number of rows in matrix B is n. So we can multiply. The product matrix A multiplied by B will have m rows and p columns. This is a normal matrix multiplication. Suppose we have another matrix. Let us have a matrix C. 1, 2, 3, 4, 5, 6. This is a 2 by 3 matrix. We can have element by element operation actually. For example, we can multiply each element of A by each element of C itself actually. Let us display C. 1, 2, 3, 4, 5, 6. So what is C dot star C? Note, this is not C multiplied by C. C is 2 cross 3. We cannot multiply C by C matrix because the number of columns in C is 3, whereas the number of rows in C is 2. So we cannot multiply. First matrix has 3 columns, second matrix has 2 rows. So we cannot multiply actually. But this particular representation C dot star, this is each element. For example, first element is 1. It is multiplied by same element in the next C. 1 into 1, 1, 2 into 2, 2, 3 into 3, 9, 4 into 4, 16, 5 into 5, 25, 6 into 6, 36. This is element wise multiplication actually. For example, we can have another D equal to 6, 7, 8, 9, 10, 11. We can have C dot multiplication D. C dot star D is 6, 14, 24, 36, 50, 66. We will try to multiply C by D. This gives an error because we cannot multiply C by D, because both are 2 by 3 matrices. We cannot multiply. Whereas first representation C dot star, each element is multiplied. C, for example, C has first element 1. First element of D is 6. 1 into 1 multiplied by 6 is 6. So we got 6. Like that. Second element is multiplied by corresponding second element in the second matrix. So that is different from matrix multiplication actually. This is term by term element based multiplication. Like C dot star is different from C star D actually. Whereas in this case C star D does not exist. I'll give another example. What is C dot? We are rising to the power of 2. See, each element is squared actually. C was 1, 2, 3. First row. In C was 1, 2 and 3. Square of that is 1 square is 1, 2 square is 4, 3 square is 9. Second row was 4, 5 and 6. 4 square is 16, 5 square is 25, 6 square is 36. So this is valid actually. Each element is squared actually. So we can multiply each element of C by another element of D or by the same element of C. C square means each element of C is multiplied by same element of C actually. That is different from C star C actually. We will see a similar example for vector. Let A equal to 2, 3, 4. This is 3 by 1 vector. What is A dot square? Each element is multiplied by the same element. 2 square is 4, 3 square is 9, 4 square is 16. Whereas A dot A doesn't exist. We can see that A, we cannot multiply vector A by vector A. It gives error. Another command in MATLAB is another useful command in MATLAB is we can initialize any matrix with zeros actually. For example, A equal to zeros 3 comma 2. If I end a line with semicolon, it does not display that. Now I type A, I don't give semicolon, just enter. A will be displayed. See, the matrix A has been initialized with 3 rows and 2 columns, all zeros actually. The zeros command initializes with zeros. Like that, we can also initialize the matrix with ones actually. C equal to ones 2 comma 3. I'll directly display this instead of entering with semicolon. Once 2 comma 3, that means a 2 by 3 matrix, all elements of 2 by 3 matrix will be initialized with 1. So this is a 2 by 3 matrix, all elements are 1. MATLAB uses some random matrices and random vectors also actually. There are two random numbers. One is uniform, another is Gaussian. First let us talk about uniform random number. X equal to rand 3 comma 2. This random number x is initialized with by a 3 by 2 matrix actually. All the elements are between 0 to 1. Let us see what is x. Rand 3 comma 2. So this is a 3 by 2 matrix initialized with a random number between uniformly spaced random number between 0 to 1. I will give the same thing again actually. It will not be same actually. I'll, the first time I got 0.81. Here I got 0.27. So both are different actually. Each elements are different actually. So each time you run, you will get different random numbers actually. All random numbers will be between 0 to 1. I will give an assignment. Try rand 5 by 4 matrix. You, you may enter rand 5 by 5 comma 4 x equal to rand 5 comma 4 and press enter. You will get a 5 by 4 matrix uniformly spaced between 0 to 1. We will see some more rand and other matrices in the next class.